Good day, judges. We are Team Locusts, and I am team leader KUIK, and my teammates are NICOLAS, TEOW, and KUIK. Our team digital advisor is Madam HASNI, and we come from Matriculation, Kedah. And what is Locusts? Locusts are originally grasshopper which transform due to overcrowding. Locust swarm will destroy all the crops, especially in diamonds, that cause huge loss of profits. So our goal is to use AI models to analyze and predict the occurrence of the locust swarm and send notification through application to the governments, organization and farmers, so they can act according to different situations and minimize the negative impacts of locust swarm.
For prediction of locust swarm, prediction can be based on the density of fresh orbit position pits in a map area. The drone with RGB camera can fly over breeding areas and take photos of the ground surface. We also predict based on temperature degree days (DD) accumulated since egg laying. Data can be collected by using thermometers to detect air and soil temperature. Next, for timing of locust swarming, we can base on total cumulative rainfall over breeding areas and normalize difference vegetation index and DVI time series. Variable gauge is used to measure rainfall, while satellite sensor measures the surface reflectance based on infra and NIR bands for the calculation of NDVI. Last, for direction and speed of locust swarming, we can base on the wind vectors. Variable radio zone can be used to track wind speed and direction at different height.
About our project viability assessment, we are able to collect sufficient data as we are using time series data, which is synced every minute according to the sensors in the weather station. The output is strongly related to the input, and it is clear and simple for commoners like us to understand. For example, we input cumulative rainfall last 90 days and the NDVI difference between 30 days to get days until swarming. We can also use orbit position bit density and TDD, which is temperature days, degree days accumulated to get flash locust density. Last, we can use wind speed and wind direction at different altitudes to understand the most favorable wind that drifted by locust swarmings and the potential direction of them.
Our sensors included weighing, rain gauge, optical camera, soil moisture sensor, air and soil thermometers, weather balloon with a radio sound, and all this timestamp sensor data will be stored in Influx database, and our satellite image can be stored in ARPAC Spark. So, how does our AI actually make prediction? We use an AI called XGBoost with a machine learning technique called supervised learning. This enables XGBoost to learn from historical environment data. XGBoost's job is to analyze it and find the complex patterns in that data that leads to outbreaks. After training, it will set a threshold and compare new data with it. Any conditions that meets or exceeds this threshold is labeled as high risk and the other is low risk. With this labeled data, the AI will further predict the possibility of swarming in an area, including its potential size, timing, direction, and speed.
So how are we going to put into action for our ideas? First, the output information is sent to the local authorities. Based on the suggested location of the swarm, local authorities get informed about the ideal time to spray the pesticide. So the output information will automate the area spraying from the drone directly into the breeding site of the locust. Secondly, we plan to develop an app with the real-time information of the locust swarms using the data collected from the sensors. When the risk level becomes urgent, the apps will send immediate notifications to the farmers so that they have an earlier preparation. In conclusion, we think that we can combat the crisis of locust swarms to create a community without food insecurity. That's all from now. Thank you.